The first minute of this script needs to grab the viewer with the urgency of a wartime briefing, because what we're dealing with is the same enemy that ancient fortress builders, medieval engineers, and Cold War bunker designers spent lifetimes trying to defeat. Moisture. Water in a basement doesn't just appear. It's the result of physics, soil behavior, and structural oversight. And anyone who studies old fortifications knows exactly what happens when water gets inside the foundations of a stronghold. Timber decays, masonry fractures, metal rusts. A structure that should last centuries suddenly has the lifespan of a cheap garden shed. The great irony is that countless people today battle wet basements with expensive modern products, while the builders of earthwork forts, stone bastions, and mountain redoubts solved many of the same problems with simple, smart engineering. So, in this opening, you draw that line clearly. If old fortresses survived monsoons, sieges, frost heaves, and groundwater surges, then, well, today's homeowners can definitely keep a basement dry with the same proven principles. Once the hook is set, the guide moves straight into highly practical information drawn from those historical methods. The first secret is understanding how ancient engineers controlled water movement long before waterproof coatings existed. Across every era, from Roman castra to 19th century powder magazines, the foundation strategy was always the same. You don't try to fight water at the wall, you stop it before it ever touches the wall. This is why fortresses carved into hillsides use graded backfill rather than just raw soil. The builders understood that, well, the shape of the layer behind a wall determines whether water sits, seeps, or drains. Many modern basements fail because the soil around them acts like a sponge. When the ground swells, hydrostatic pressure pushes against concrete until water finds the smallest flaw. The historical method was simple: remove water's ability to build pressure. You can apply this same principle today by digging back the soil around the problem wall, laying a wedge-shaped layer of crushed stone, and, compacting it lightly so water moves downward instead of inward. Even a narrow band of gravel, 12 to 18 inches wide, can outperform expensive coatings because it provides the pressure release that ancient engineers relied on. The second secret is how fortifications use controlled exit pathways to lead water away from foundations. In many historical bunkers, especially those built in Central and Eastern Europe during the build-up to the Second World War, the core strategy was to let water escape with minimal resistance. Channels were carved beneath the foundation so groundwater would naturally seek the trench rather than the interior. These drains usually led downhill from the structure, ensuring that gravity did most of the work. People today often think waterproofing means trapping water out with membranes and plastic layers, but the old engineers knew that trapped water always finds a weak point. A dry basement doesn't begin with blocking water. It actually begins with routing water. For a modern homeowner or off-grid builder, this can be replicated by carving a narrow trench around the foundation edge, lining it with filter fabric, filling it with gravel and placing a perforated drain pipe at the bottom. The pipe does not need to be elaborate. Many early 20th century military engineers used clay tiles, which worked for decades. What matters is slope. Even a slight downhill angle creates a dependable escape route. This method is especially effective for homes built on sloped lots or in areas with heavy clay soils that trap moisture. The third secret is using barrier layers that allow structures to breathe instead of, suffocating the walls. Looking at old field forts or magazines, you'll see that builders often placed breathable moisture breaks between the earth and the wall. These were not waterproof membranes. They were layers of tar paper, bark sheets, pitch-soaked cloth or porous stone. The goal was always the same: prevent liquid water from touching the structure, but allow vapour to escape so humidity never built up behind the barrier. This is why so many older structures remain intact, while modern basements wrapped in plastic still grow mould. A practical way to apply this today is by lining the exterior basement wall with asphalt-treated building paper before placing backfill. This creates a moisture choke point, the same way historical builders layered tarred felt behind wooden bulwarks. It won't trap water like plastic does, and because it breathes, the wall remains dry enough to avoid long-term deterioration. For interior moisture problems, a similar principle applies. Leave air gaps behind panels, use lime-based coatings instead of sealed paints, and allow vapour to escape naturally rather than trapping it behind impermeable surfaces. The final secret is soil management, one of the oldest engineering tools in the history of fortifications. Ancient ramparts, colonial bastions and mountain bunkers all relied on shaped soil to direct water. If the ground around a basement slopes toward the walls, no amount of interior work will save it. But, if the grade pushes water outward, just a few inches over several feet, most moisture problems, they sort of solve themselves. Fortification builders shaped landscapes deliberately, making sure that rain never collected near walls. Homeowners today, though, often forget this crucial step. Even a simple regrading project that directs runoff away from the house can, quite remarkably, permanently stop leaks that people spend years trying to fix from the inside. If this deep dive into Fortress-era foundation strategies helped you understand how to secure a dry basement with time-tested methods, make sure to subscribe to Thermal Vault. And, share this guide with anyone fighting moisture problems in their home or building off-grid structures. More historical engineering breakdowns are coming, and each one will give you tools that professionals charge thousands to share.